After the CLEAR report was published by the BCLA, James Walton et al. Produced a corneal GP grading scale. We can use this to consistently and effectively grade the fit of our corneal GP lenses. Now, movement is graded in a series of numbers depending on how much the lens actually moves. If the lens is moving in excess of 2 millimeters, we would grade that as a +2. If the lens moves between 1 to 1.5 millimeters, we'd grade that as 0, etc. The scale also gives us the ability to grade centration. So if the lens is well centered, we would grade it C. If it crosses the limbus, then we would grade it L. Another aspect of the grading scale is also fluorescein fit, which we will discuss further on in the presentation. When we're assessing the fit of a corneal GP, initially we use white light with a low magnification. We're looking to see how accurately the lens centers, how much it moves, and grading these details accordingly. What we want to know is, does the lens move with the blink, or does it move with the lids? So is it a lid attached fit? Does the lens recenter quickly and accurately, or does it drop down in an arc, indicating it may be flat? We ask the patient to look in all 4 principal meridians, checking for lag, to see if the lens will cross the limbus or not. Also, we want to push the lens up gently. Now, with some of the steeper fits that may be slightly tight, we may struggle to get the lens to move with lid pressure. Again, we would grade this accordingly. If the lens is relatively old, we want to look to see if it's damaged. Are there any scratches or chips out of the edge that we need to note, and recommend that the patient replaces the lens. And finally, if there is some form of toricity to the lens, generally it will have an indicator to show you where the base direction is. So is this sitting in the correct position? Do we need to make any alterations? Once we've done this, we can then move on to further examination. In this video, we've used a low magnification, fairly diffuse illumination. What we're looking for is to see how the lens moves, how well it centers and how well it recenters. And also, by holding the lids out of the way, we're checking for limbal crossing in all 4 principal meridians. We're now looking at how to grade a corneal GP lens with fluorescein. Using the Wolfson scale from the CLEAR report, we look at the intensity of the fluorescein pattern in the center, the mid-periphery, and at the edge. Using values between plus and -2 to grade the intensity, +2 being the brightest, -2 being touch, and 0 being alignment, we're able to grade the lens fit in each of the 4 principal meridians. So we want to look at the corneal GP lens with fluorescein. So we instill the fluorescein, and it's quite important to allow the fluorescein to permeate properly behind the lens and also to wash off from the front surface of the lens. If we try and assess the fit too early, all we'll see is front surface fluorescein, and this will actually disguise the fitting pattern behind the lens and give us an erroneous judgment. So it's important to wait 1 or 2 minutes before we have a look at the fluorescein panel. Initially, it's a good idea to use low magnification, or if you have one, a Burton lamp. This gives you an overview of the whole fit of the lens and the appearance generally. Once we've done that, narrow the beam and increase the magnification, and have a look at the fit and the intensity of the fluorescein in those 4 principal meridians. Grade how bright that fluorescein is using the Wolfson scale, and note it appropriately. This will mean that a practitioner following on from you will be easily able to see how that lens fitted on that particular day. So we've instilled fluorescein into the patient's eye. We've allowed for that fluorescein to form the fitting pattern properly. As you can see from this video now, you can see the fluorescein behind the lens, and it's showing an intensity centrally of about +1. In the mid-periphery, it's aligned, so we're looking at a value of 0. And at the edge, again, we're looking at approximately +1. It's also useful to measure the width of the edge clearance. And this one's quite narrow, but probably no more than about 0.5 millimeters. If we record all this information appropriately, it can make it very easy to see exactly how that lens is fitting, and also to see what happens when we make any adjustments to the lens fit.